All right, good day, everyone. Tony Lewis here, and we're going to walk you through papermaking industry 4.0, autonomous control using artificial intelligence, and it's really the Solenis journey into digital and advanced analytics, and really kind of walk you through a little bit of our journey and kind of where we're going with this technology and how we're creating value for our customers. But the more exciting part is really building some use cases around things like advanced analytics and AI and how they apply to the paper industry. So with that being said, let's get started. So looking at here, we've got some mill challenges, right? Anyone who's been in a paper mill, we've got a wealth of data, and the historians, customers and folks continue to put more data in there. It gets more complex, and it's tough to dig through that. Not only from it's the health of the data and how it's being stored, but also just from the sheer volume, right? And when we go back in there and send process engineers or folks to dig through it, it's very time consuming. So with that being said, that continues to grow, and that's a challenge, and how you manage that. Going to the next stage, our processes in the papermaking process, they're continuous and they're highly variable. There's certain things we can control very well, but then there's a lot that changes, especially because some of the feedstocks that come in there, whether it's virgin pulp, recycled, all of those things, conditions of the water, all of those things are dynamic. Even how people control the paper machine, shift to shift or day to day. Those variability things kind of grow, and they're tough to manage. And we are constantly, our teams are challenged in the mills, our customers' teams, on how to manage those variability, sources of variability. And then we're also seeing root cause identification, because with all that variability, there's the challenge of, okay, something's not where I want it to be. How do I understand what is the root cause so I can fix it in right now, or I can develop a strategy to kind of, mitigate it long term. That's another challenge, and we hear that often from our customers, trying to get to the root cause, and using digital to kind of get there a little bit quicker. And then the other challenge is really blind decision making. So we've got a wealth of subject matter experts who have a lot of experience. And a lot of that falls into the art of papermaking. We hear about it, right? And that's the gut check, the intuition and the knowledge that some of these subject matter experts have. But that doesn't always work out, because some of the experiences we have may not apply to the new state of the process, or just we're in a different process and it's different. So all these challenges together are what we're faced. And now really, how do we utilize digital advanced analytics, new tools, beyond things like, statistical process control and basic troubleshooting. Now we can kind of digitize and take make use of some of the new tools out there and really drive some value. And we're going to kind of walk you through that here. So kind of, we've all kind of seen charts like this, and it's really to kind of show the gradient of how you move up the scale from human interaction and interpretation into kind of real-time results. So you're looking at analytical robustness as the more complex solutions go along the lower axis. But then as you kind of go up there, you can get to higher pieces of value. So really on the lower end, these are all things that we're very familiar with, the descriptive and the diagnostic phases. This is the life of the process engineer or the folks out on the machine floor, right? Measurement of things, benchmarking, centerlining, those are really the traditional methods. And then you start to go up into the root cause, let's draw some correlations, let's do some multivariate analysis. Those are the basic statistic ends that we kind of throw into the mix there. And then we really start to go into the predictive and the autonomous control pieces. And that's where things like OPTIX can come into play, which Solenis has developed. And that's really moving beyond just doing 1D correlations, using things like predictive analytics, multi-dimension non-parametric modeling, and then really driving into autonomous control. And that's really just taking things we've identified with and built with predictive models, and now basically controlling that action through autonomous control. And we'll walk you through some examples there. But really, key takeaway here is as we move up the chain, the value increases, and we really can now get at some value opportunities that we just couldn't get at before. So again, just level setting on how we see with OPTIX some of the key fundamentals of advanced analytics. And this isn't all inclusive. This is just a brief summary of how we kind of view things when we approach it with OPTIX and how we're trying to leverage digital with chemistry and helping our customers solve problems. So we've got a cloud-based platform. We need that basically to run a lot of the computations. On-premise can be challenging. It is challenging. So our platform is cloud-based. The paper-making knowledge is a key input here, right? It's not just about taking data, shoving it in a computer or some kind of platform and getting the answer. The paper-making process knowledge is needed on how to organize the data, how to look at the problem, and then even some of the inputs into the methodology of how they need to base some of the assumptions and whether the machine learning algorithm thinks. So all these kind of play into it. Our focus really to start with is around paper machine properties, and we'll show you some examples. So really the things we can't really get our hands around in real time, like wet tensile, strength properties, softness, there's a delay in kind of when we get this information and when we can do it. So it's really kind of, these are the inputs we're looking at along with the real-time data from the historian. And we put those into, hey, our AI machine learning model. We build these models in the platform. And then the outcome is actionable insights, but even more so from actionable insights, we're going to see we can even derive that into autonomous self-maintaining solutions. Because actionable insights could also be somebody goes and takes actions manually, but we're trying to drive it even further to put people in a supervisory mode. So when we look at OPTIX under that same premise, a little more granularity, we got two real big buckets that we look at, do it yourself, and OPTIX can do it for you with autonomous. And we'll tell you a little bit about our journey here. So on the predictive analytics side, hey, you build some real-time measurement of quality parameters on the fly, to make decisions on the fly. And hey, like here, you got a strength prediction or whatever quality parameter you want to predict. And we've got some dashboarding. So some visualization in building the model is the first piece, because if you can't see or measure something, you can't improve it. And then once we get that model, right, if you move to the left there, we can get some insights so you can see what predictors are driving the model. We can look at over time and see what predictors are selected, and also get some deeper insights around that. But from our experience, that kind of leads into, that's more longer term looking at the process over a longer period and isn't always actionable in the moment. So really where we've evolved is kind of pushing things to autonomous control and really focusing these models on, hey, how do I improve the controller utilization of my chemistry? And we'll walk you through an example here that you can see with wet tensile. Think of it current state. Hey, an operator gets a lab value. They interpret that lab value. They may or may not make a change. And there's a lot of variability in that based on the person, variability in the test. With autonomous control, we can kind of cut through and manage all that and just drive it towards the outcome of, I want to be at target and I want to use the right amount of chemistry. So it's kind of letting the AI just cut through all that decision-making process and do it on a more consistent basis. And that's where we see the real value, because you get immediate optimization and you get immediate value. And that's a key piece with these digital solutions. You really want to look towards driving it towards an outcome. Again, just to kind of walk through the piece, right? You can make a real-time prediction, which is great. Now we have visibility. And then if we look at our process, so now instead of every hour or every hour and a half, we would get some of these tests, we can see it in real time. As things trend down, we can potentially make some moves, but there's still a human component in there, right? And that doesn't really address all the variability. Case in point, one operator may want, he or she may be okay with running slightly below target or at target. One may want to run a little bit higher. So how do we kind of mitigate and take that to the next level? It's really looking at autonomous control. So now we take those real-time predictions, we marry them with a control strategy, and we utilize one of our IoT controllers from our OnGuard product line, which is very robust in connecting many ways to the customer systems. And then we optimize an input. We're starting with chemistry. But we're also getting experience in working on, hey, how do I look at fiber blends and other things on the paper machine once people get comfortable with autonomous control of chemistry. And again, just to reiterate, this is about real-time value capture. We have folks in our customer sites that are servicing our programs, working with our customers, and they really do a good job to ensure that, hey, every drop of chemistry is being as efficient as possible, but we've got limitations because they're not there all the time and they're not watching the process all the time. Here's where we can bring in something like OPTIX autonomous control to really take this to the next level, because it doesn't stop. It just runs all the time. So here's a little bit summary of a great case study we had around wet tensile on a towel machine in tissue. You can see on the top, this is the quality parameter. The trial start is the yellow line. So the OPTIX autonomous control was able to drive down to target adherence by making its control parameters in context of all the variability going on the paper machine. And then we had, in this case, a 25% optimization in chemistry, which is money immediately back in the customer's pocket, just in chemistry. There's also other benefits that they get from that. We know at times when you overfeed chemistry, it's not just cost, but that can lead into deposition, other impacts with other parts of the process. So there's also ancillary value that's created just beyond, the chemistry optimization. And again, just to highlight, hey, there's some chemistry optimization, reduced quality variation, improved target adherence with this, another key thing, more consistent quality. And these last two items are pretty key because you want to be able to bring these solutions easily to the customer. There's not a large CapEx capital investment. That's one of the benefits if you design your digital project properly. You can bring it out quick. And then also we are talking about data in IT components. Fast, secure, and implementation is key. So working with our customers' IT groups to make sure this data is secure is another key part of delivering these solutions. Again, just a summary of the foundation of, hey, how do you improve a process, right? You look at the historic blue bell curve. A lot of variability in there. The whole goal and what autonomous control can help out with is basically thin up that bell curve, make it thinner, and then that allows you to make a mean shift, kind of get closer to where you want to run your target, possibly adjust your target as a whole. And you can see in just that case study, 33, we've even seen some cases up to 33% improvement in wet tensile variation, and then also 98% improvement in target adherence when we run autonomous control. So really making a big impact at some customers. So in summary, driving, some of the benefits, with AI stuff, obviously we talked about chemistry, and that's core to Solenis's business, but it's also just reduced process variability. You're not displacing people. You're just, bringing these digital solutions to kind of mirror a lot of the supervisory controls that already exist in things like weight control, but now we're just able to do it with different tools where we couldn't before. And then getting more increased target adherence. It's all about a continuous process, continuing to level out that variability and have consistent operation. And these solutions can, when properly applied, can help with that. The real-time process insights are key. Like I said, they're a little more longer term. Once you get enough data and build the model, you can start to look at how your process is reacting, and that could decide, help you make some decisions on how do I change how I run my process. Maybe I'm not doing things the way I want to, and you can create some plans to change things. And then it's the on-the-fly decision making, right? Whether I'm autonomous or just taking action on it. And then key things that we've also like to share, key learnings and requirements. When you bring in these AI and machine learning and advanced analytics, cultural readiness is a key piece. Gotta be willing to try things. I always draw the analogy, AI and machine learning is similar to a person. If you think about how one learns in their real life, you make mistakes, you learn from your mistakes. So do these technologies. So it's making sure you control that experimentation, but also that your culture is ready to do that. Input from subject matter experts. I think these digital technologies are going to change how these subject matter experts work and how they're utilized, more so on the front end of developing these solutions. And then you can kind of, like you said, once they're autonomous, they're maintained, but less about, hey, bringing in a subject matter expert to work and break down a problem, you can use them to kind of help develop these digital solutions on the front end because they really have the understanding of the process. Alignment of IT and data security. This is a whole nother topic in itself, but it's a huge part. What are you doing with your data? How are you storing it? That requires a whole strategy and approach, and it's really pivotal to the discussion. So don't want to lose sight of that. Willingness to share data. Again, if you can securely do it, which you can, there's many ways to do that now. Paper machine data is, if we share banking data and other secure things, you can do it with operational data very, very securely. But having that willingness to share and interact with suppliers is key too, because then you can leverage other output sources and other resources to kind of bring these solutions to you. And then really it all boils down to a business plan to measure the value. Digital projects are great, but if they don't go anywhere to really move the bottom line, whether it's for the customer or the business, they're not going to fund themselves. So keeping that in mind is, why are you trying to do this and what are you trying to drive for? And I think, we've tried to show that in some of the examples where our focus is in really trying to make sure our chemistry is digitally enhanced to kind of create value for the customer. And with that, this concludes our presentation, and I look forward to fielding some questions in the question and answer portion. Thank you.